Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Beaker by James Sinclair, and we have a nice little beaker here with I guess it's a thermometer. I'm not sure what this part is, but we have a beaker here. And anyways, here are the rules. Normal Sudoku rules apply, and all clues are standard. So normal Sudoku rules apply, which means that we have the digits 1 through 9 appearing in every row, every column, and every box once each. Thermometers. Digits on the thermometer increase from the bulb. So you're always increasing from the bulb to the tip. So a potential example of the thermometer would be 1, 2, 4, 5, 7, 8, and 9. That's possible as a thermometer. It's always increasing, right? If say we had this as a 9, this would break because obviously 9 does not increase to 7. So that's how thermometers work. Entropic lines. Digits along the orange line, every set of 3 adjacent cells must contain one low digit, 1 through 3, one middle digit, 4 through 6, and one high digit, 7 through 9. So for every 3 cells, or every 3 cells along an orange line, you have to have one that's a low digit, 1 through 3, one that's a middle digit, which is 4 through 6, and one that's a high digit, which is 7 through 9. And that always occurs along the line, along the orange line. So these 3 have to be different sets. These 3 must have one from every set. These 3 must have one from every set, etc., etc. So these 3 have to have one from every set, etc., etc. Digits in cells separated by a white dot are consecutive. Not all dots are necessarily given. So for example, if this were a 3, this would have to be a 2 or 4 to be consecutive with it. And consecutive just means that they have a difference of 1. Find more puzzles like this at artisanalsudoku.com. So that's just a plug for James Sinclair's website, I would assume. But yeah, if you like this puzzle, go visit his website, and hopefully you'll enjoy it. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, first things first, I like numbering the thermometers from the lowest digit to the highest digit. So this could be 1. This has to be greater than this, so this is at least 2. This is at least 3, at least 4, at least 5, at least 6, at least 7. The highest number, then we go back down with the highest number. What's the highest number here? This has to be the highest number of 9, obviously. So this is 7, 8, or 9, which means this has to be less than this, which means it has to be 6, 7, or 8, which means this is 5, 6, or 7. This is 4, 5, or 6, 3, 4, 5. 2, 3, 4, or 1, 2, and 3. Interestingly enough, this has to be the low set, and this has to be a high set. We don't know about these, though. This has to be a middle set, 4, 5, or 6. So I like coloring these various colors. So this could be 6 through 9. This could be 1 through 4. And then I'm going to randomly assign colors, for these sets in the beaker. Because we know every 3 has to be a unique, you have to have one of each set. So let's make this, I don't know, yellow, orange, and this one's purple. Well, if that's the case, what about these 3 digits? We know we already have one from the yellow set. We have one from the orange set. What set is remaining? This has to be the purple set. or pink set. I like saying pink because it's less words, less syllables, but and then we have in this 3 set, you have an orange, one from the orange set, one from the pink set. What color must this be? It has to be yellow, right? So we know that every third digit along this entropic line has to be the same set. So therefore, this is the same as the third one that's away from it. So this would be orange. This would be the same that's the 3 away from it along the entropic line. So this is pink. Therefore, this is yellow, orange, pink, yellow, orange, and pink and yellow. Okay, so what does that tell us? Well, we know orange cannot, well, that's not necessarily true. Entropic line, oh, I forgot to say these are white Kropke dots. One thing we do know. If this is a 3, this would have to be 2, and therefore this would have to be 1. But we know one of these digits is a low digit, right? Because we have all 3 of the sets here. But by using this as a 3, and this a 2, and this a 1, we have eliminated for these cells the possibility for being a 3, a 2, or a 1. That would break the entropic line rule set, so therefore this can never be a 3 then. Similarly, this can never be a 7, because if this is 7, this is 8, this is 9, which means none of these cells can be 7, 8, or 9, but we know by the entropic rule set one of them has to be. So this can never be 7, 8, or 9. Or this can't be 7. Well, this has to be greater than 4 or 5, so this can't be 4. This has to be less than 5 or 6, so this can't be 6, so therefore this has to be a 5, which makes that 4, and therefore this is 6. So these are all the middle digit. This can no longer be 4, so this is 2 or 3. This can't be 1. This can't be 3 now because this has to be smaller than this. This can't be 6, so this is 7 or 8, which means this has to be 8 or 9. 1 and 2 can only be next to 1, 2, or 3, right? 1 can only be next to 2, 2 can be next to 1 or 3. So that works that way, which means this is a low digit, and this is low too. We know there's one low here, right? Similarly, if this is 8 or 9, it can only be next to 7, 8, or 9. So this is also 2 highs. Well, the thing is, orange has 2 digits already in column 6 and 2 digits already in row 6. So if you try to make orange the low, the problem is in row 6 you would have 4 lows which contain 4 cells which would contain 3 digits only possibly. And that's not possible, right? So orange cannot be a low digit. Now if we try to make it a high digit, that would make 4 high digits in column 6 then, which would break the puzzle again, right? Because the only high digits in this case are 7, 8, and 9, and you can't have 4 cells be filled with 3 digits. So therefore, orange has to be the middle digit. So these are the middle digits. In addition, we know that we have 1 digit that has to be low. So in the rest of row 6, you cannot have another low digit, right? Because one of these 3 is low. We already have 2 other low digits. So all 3 low digits are accounted for. So the rest of the digits can never be low. Similarly, in column 6, we have 2 high digits here, and one of these has to be high. So we have accounted for all 3 high digits now in column 6. So this can't be high then either. This specific cell then must be a middle digit, with the remaining cells being here then have to be high, right? Right. So the remaining digits in row 6 have to be high because we know one of these is essentially a low digit. So both of these have to be high. And then similarly, both of these have to be low. Well, the thing is, a high digit can never be consecutive with a low digit, right? 7, 8, and 9 is not consecutive with 1, 2, or 3. Therefore, it can only be consecutive with another high digit or a middle digit, but we know that of these digits here, we already have accounted for where the middle digit is. So this is either high or low, cannot be low, therefore the pinks are all highs. And you could use similar logic here to deduce that, because you know that the lows have to be next to only lows or middle cells, but the problem is we've already defined the middle cells, therefore the yellow has to be low. So these are all low. This is a low, which means this is 1, 2, or 3. It's consecutive with 1, 2, 3, or 4, but then this has to be 1, 2, or 3 also because the 4 is already here. So this has to be a low. Therefore, we have 3 lows in row 7, which means the rest of the row cannot be a low digit. So this can only be a middle digit, and it has to be 4, which means it's next to 3. So this can never be 3. One of these is a 3. Well, 3 can only be consecutive with another low digit if it's 2. So then this is 2 and 3, which forces this to be 1, which means this can't be 1. So this is 2. 2 is consecutive with only 1 or 3 here. So 2 has to be one of these 2 cells. We're not sure which. Actually, it was always consecutive, so it always had to be part of that cells. So this is always 1 or 3 then. These 2 are consecutive, so you have to have an 8 with a 7 or 9, so this must be 7 or 9. This one we're not sure about. This is always 4. This cannot be 5 or 6, even though it's a middle, so therefore it must be a 4. Well, low can only be next to another low, or it can be next to 4. So therefore, we know then this is low, which means this has to have a 2 with a 1 or a 3, but this can't be 1. We don't know what that is then. Let's see. This cannot be 4 or 5, and it has to be a middle digit, therefore this must be 6. Now, highs can only be next to high digits or a 6. Therefore, since we already have a 6 in this box, this has to be a high. So therefore, this also has to be 8 with 7 or 9. We're not sure which, though. Therefore, we have all the high digits in row 5. We have all the low digits in column 5. And this also is a high digit. I'm not sure what that tells us. These cannot be high, so one of these 2 is high. That doesn't really tell us very much. This cannot be 4 or 6, so it must be a 5. This can't be 5 or 6, so this must be 4. This can't be 4 or 5, therefore this must be 6. This is consecutive, so this cannot be 8. Or, sorry, one of these 2 has to be 8, which means this cannot be 8. So this is 7 or 9. If it's 7 or 9, it has to be either with 6 or 7, 8, or 9. Since we have a 6 here, this cannot be a 6, therefore this has to be a high, which means this has to be an 8. because it cannot be 7 is consecutive only with 6 and 8, but 6 is not possible, so 7 would be consecutive with 8, and 9 is only consecutive with 8, so this is 8. This has to be 7 or 9. This is only consecutive with 6 or 8. And we know one of these two cells has to be an 8 because 8 is only consecutive with if you have two digits that are both high and that are consecutive, one of them has to be an 8. So this can never be 8, which means this has to be a 6, which makes this 7, this is a 9. This has to be a 7-8 pair then. So this is middle. This is 7 or 8. This can't be 9. Oops, cannot be 9. What else do we have here? Not sure. We have 5 through 9 left over here. This cannot be 5 or 6, so it has to be 7, 8, or 9, which is a high. Six cannot be any of these cells. Where is the 6 in row 7? It has to be here. So this is a 6, which we will paint as a green cell. So either this is 5 or this is 5. We're not sure which. So we know 8 is one of these two. 8 is one of these two. If this is 8, this has to be 7, which forces that to be 9, which makes that a 7. So if this is 8, again, if this is 8, this has to be 7, which forces this to be 9, which makes that a 7. If this is 9, obviously this would have to be 8. This would be 7, and this would be 8 then, because it could not be 7. So we have a 7, 8, 7, 8 pair in row 5, which eliminates 7, 8 from the rest of the row. Therefore, this must be a 9, which forces this to be 8, which makes that a 7, which makes that 8, which makes that 7. This 7 means this is an 8, which forces that to be 7 and forces that to be 9. Let's see. What else do we have? Oh, yeah. So similarly here, if this is 2, this has to be 1, and this is 3. If this is 3, this is 1 and 2, so that's fine. But, okay, so what is this cell then? If this is 2, this is 1, which makes that 3, which makes this a 2. If this is 3, this becomes 1, this is 2, and therefore this is 3. So now we have a 2, 3, 2, 3 pair in column 5, which eliminates 2 and 3 from the rest of the cells in the column, which makes that 1, which makes that a 2, makes that 3, which makes that 2, which makes this 3, which means this can't be 3, this is a 1, that therefore this is 2, that must make this a 3. Okay, now what else do we have? 2 cannot be here, therefore 2 has to be one of these two cells. 7 is one of these two cells. The rest of this, okay, so this cannot be 7 either. Can't be 2, it can't be 7. What else can it be? This has to be 5. Therefore, we know this is a 2-7 pair. This is a 2-7 pair. This is 5 in the middle. This can't be 5, so this is 1 or 3. 5 has to be one of these two. I'm not sure which. Um, 6 cannot be here, so 6 is one of these two cells. 4 cannot be here, so 4 is one of these two cells. Interesting. 8 cannot be here, so 8 has to be one of these two cells, which means 8 is one of these two cells. What about 4? Hmm, 9 has to be one of these two cells. Okay, so and 1 has to be one of these two cells. Okay, so one of these could be 1, one of these could be 9, one of these could be 4, and one of these could be 6. What's the remaining cells here? It's 3, 5, and 8, but this can't be 3. And this can't be 8, so therefore this is 5, which makes this a 3-8 pair. This is 5 in the middle. What's left here? This has to be 7 or 9, because it cannot be 8. We have 1 and 6 possibly here, or 2. So it's 1, 2, 6, 1, 2, 6. This cannot be 3. It cannot be 2. It could be 1, no 2, no 3, no 4. It could be 5. Cannot be 6, 7, 8, or 9. So this is 1 or 5. This has to be 1, 3, 5. It cannot be 2, but it could be 6 here. So this could be 6. Hmm. Hmm. What can these two digits be? It cannot be 1 and 2 because the 2 is already in the box. It could be 3, 4, but it would specifically have to be 3 there and 4 there. It cannot be 4 and 5 because if this is 4, this would have to be 5. But then we already have a 5 there. It cannot be 5 and 6 because of the 6. It cannot be 6 and 7, obviously, because of that. It could be 7 and 8. That's possible. Or it cannot be 8 and 9, because if this is the only possibility for 8, and therefore that would have to be 9, but that would be eliminated by that one. So this is 4 and 7, or it's 3 and 8. Sorry, 4 and 3, or it's 7 and 8. 3 cannot be here. 3 cannot be here. 3 cannot be here. Therefore, 3 has to be one of the consecutive ones. It can only be consecutive with 4 because the 2 is in the box. So this must be 3 and 4 specifically. We can probably do something similar with the 7, right? Yep. Actually not. This dot is in a separate place. Interesting. So it can't. We know 7's one of these two. I guess it could be 7 and 6, but 7 could be outside of it even. So what are the possibilities here? So this is a low, and this is a middle, which means 4 is one of these two cells here. 4 cannot be here, or here, or here, so 4 is one of these two cells here. Where is the 5 in column 1? Cannot be any of these cells because of these 5s, therefore it must be here. So this is a 5, and it's the middle. This can't be middle or low because of that low. Therefore, this must be a high. So this is 8 or 9. This we don't know yet. Here we have 6, 7, 8, and 9, but this can't be 6 or 8 and 9, so it must be 7. So this is a high and it's 7. This can't be 7, this can't be 7. These have to be 1, 2, 3, and 7. But 7 cannot be any of these 3 because of this 7. Therefore, it's a 1, 2, 3 triplet in box 1 or column 1. Therefore, this can't be 2. This must be a 7. Therefore, this is a 2. So this is a low. This is a high. This cannot be 1 or 2, therefore it's 3, which means these can't be 3. But it's 3 in the corner, so we celebrate. This has to be 4. Cannot have a 6. It could be 8 or 9, right? So 4 with the 8 or 9. This can't be 8 or 9, so this must be the 4, which means this can't be 4. This has to be a high. This is a middle, which means this has to be the 4 in the middle. So this can't be 4. These all have to be low. So this is also 1 or 2, so this can't be 1 or 2. This must be then a 3. 3 can only be consecutive with 2 and 4, but this can't be 4 anymore. Therefore, this must be 2, which makes this a 1, which makes this 2, which makes this a 1. So this would also be low here, which means this can't be 2 anymore. And this can't be 3, where the 2 with 3 in box 6, it has to specifically be, and this can't be 1, so this is 5. Which makes this a middle. 2 and 3 specifically have to be here. So this is 2, this is 3, they're both lows. Where is the 2 remaining now out of the remaining cells? We have 8 of them, so we should be able to determine the last one, and it's here. So this is 2. And it's blue. Let's see. What do we have remaining here? Now this is probably mostly Sudoku. This can't be 5. What are the remaining cells in column 9? It has to be 5, 7, 8, and 9. So this is 5, 7, 8, 9. This is 5, 7, 8, 9. But this can't, none of these can be 7. So we have a 5, 8, 9 triplet now in column 9, which eliminates 5, 8, and 9 from the rest of the column. So this has to be 7. In addition, so that's a high. This has to be a high, and it's a 9. So this can no longer be 9. These are now medium. So it has to be 5 and 6. This can't be 5, so therefore that's a 6, which makes that a 5. This can't be 3, therefore this must be 8, which makes this a 3. That 8 means this is a 9. That can't be 8 or 9, so this is 6, which makes that an 8. And as I said, this is just normal Sudoku. We're just coloring things in just because, I don't know. Looks cool? I don't know. This has to be 7 or 8. Of the remaining cells, this must be a 1. So this is low. We have 3 lows here. So this can no longer be a low. Whereas the 1 then, it has to be here. So this is a 1 and a low, which makes this a high. This has to be, this can't be 8, therefore this is 9. This cannot be 5 or 9, so this must be 8. This can't be 8 anymore. This can't be 8 anymore. This has to be 7 or 8. The remaining cell here has to be a 4. So then this is a high. This is a middle, which makes this a 1, which makes that a 9, which makes that 7. Therefore, this is 6. This is 4. This has to be 1. This is 6. This can't be 7. Therefore, this is 8, which means this can't be 8. So this is 5 or 9, but can no longer be 5. Therefore, this is a 9, which makes that 5, which makes that 9. This can't be 7 anymore, so therefore this is 7. The remaining cells are now 8, and we're just going to color these. These are all high. This is a high, and this is a middle, middle, low, low, low. This is a high, and these two are middle. So the last one is a middle, and it's a 5. Pretty cool, actually. Interesting how they use the beakers with the crop key dots. Yeah, fun little puzzle. And I hope you had a fun time solving it too. And I'll see you next time on Frank Puzzles. Take care.